Okay, we're gonna try this. I'm sorry for the echo, but it's the only way I know how to record with this mic. So if I stop or stutter, it's because the speakers are echoing in my ears. All right, take a look at your worksheet. It says 9.5. Solving quadratic equations by using the quadratic formula. All right, here you can see the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. This will get you your roots whenever you are trying to solve a quadratic. So if we take a look at just a generic drawing here of a graph, the x values, what you're trying to find out by doing all this stuff here is you're trying to find out the x value here and the x value here. Those are very important in algebra. Right, and they would be two different x values, so this would be x sub 1 and x sub 2. So you would find two different x values. So that's what the quadratic formula is used for, just to find those two locations. There's a special part of the quadratic formula called the discriminant, and it's just the stuff underneath the radical right in here. If we know the value of that discriminant, we're able to know a lot about what type of roots our quadratic has. And you don't need to memorize a new formula. Sure, the discriminant is worth b squared minus 4ac, but it is part of your quadratic formula. So memorize your quadratic formula, and it's just the stuff underneath the radical. If we take a look at the values that could be here, let's say we were trying to evaluate a quadratic and it came to be the square root of 10, or let's say it was the square root of negative 5, or the square root of 36. These three options, oh, one more, the square root of 0. These four options give us four different types of graphs. Okay, this first one, what is the square root of 10? I don't know, you don't know, you need a calculator. It's 3 point something, but it's an irrational number. So when you get a number under the radical that you don't know the square root of, it's an irrational number, which means you're going to get a decimal whatever for the x values. So you're going to get two real places where the parabola crosses the x-axis. They're just going to be irrational numbers. They're going to be long decimals. Sometimes they want you just to leave it in the radical form. All right, if we skip down to this 1/3 down here, the square root of 36, well, we know that one's just 6. So if the discriminant, if this part underneath the square root is worth 6, then whatever minus b is, negative b is, we're just going to do plus or minus 6 and then divide it by whatever 2 times a is. So in essence, square root of 36 and the square root of 10 are giving us very similar answers. They're giving us two real x values that we're going to be able to put on a graph. This one's going to be an easier one to graph than square root of 10, but they're giving us two answers. That's why they're similar. The last one, the square root of 0, well, the square root of 0 is just 0. And the square root of 0 is only going to give us one root, because if I look at my formula, if I have negative b, whatever that is, plus or minus 0 over 2 times a, that's a 0, the plus or minus really isn't doing anything. If I add 0 to something, it's the same as if I take 0 away from it. It means it's not changing, which means that I have negative b over 2a. All right, and that's going to be a single root, and that's what they're talking about with case 2, is if the discriminant equals 0, then you're only going to have one root. And what that's going to look like in a parabola is something like that. All right, where the only point that touches the x-axis is the vertex. So we'd have negative b over 2a and the function value of negative b over 2a. There's your vertex formula. Your fourth situation really, is this guy right here. What is the square root of negative 5? Well, it doesn't exist. The square root of a negative number, there's no two numbers I can multiply together to make them negative. So if I did negative, just for instance, negative 2 times negative 2, that equals positive 4. So there's no two negative numbers I can multiply together and get a negative number. So the square root of a negative doesn't exist. We've actually come up with a symbol for it. It looks like a little cursive I. It's useful in some applications with electricity, but what it means for you here is a graph that doesn't have any roots. So the parabola might head towards the x-axis, but it's going to turn away before it crosses it. So it doesn't have any roots. It doesn't have any place where it's touching the x-axis. All right, so those are your three options. You get no real roots, which means a negative under the square root. You got one real root, which means that you get a 0 under the square root. And then you get two real roots. Two real roots will happen when you have a positive number under the square root symbol. And you go a step further and say that if I have a positive perfect square like 36 or 100 or 25, then I have two rational real roots. All right, let's take a look at those examples that are on the worksheet. They're all worked out for you, but sometimes that's not helpful. So I'm going to do them step by step. You can follow along. All right, the first one says 12x squared plus 5x equals 4. And we want to state the value of the discriminant for each equation and then determine the number of real solutions for the equations, or roots. Okay, step one, this has got to equal 0. I can't say what A, B, and C are unless it equals 0. So I'm going to move this minus 4 to the other side. So I'm going to have 12x squared plus 5x minus 4 equals 0. So I can say A equals 12, B equals 5, and C equals negative 4. Now, look at what would happen if I just used a positive 4 for C. It would be a different number. Right? We want to use the correct values for A, B, and C. So let's take a look at the quadratic formula again. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure your fraction bar goes across the whole numerator expression. A lot of people will cut it off right here, and that's no good. All right, so all I need is the discriminant portion, which is right here. So b squared minus 4ac. For this one, b squared is going to be 5 squared minus 4 times 12 times negative 4. All right, first, that's going to equal 25. Now I look here and I got negative. I treat that like a negative 4. And I'm going to treat this like a negative 4 because it is. All right, so a negative times a negative. This is going to be a positive 16. So it'd be plus 16 times 12. All right, we're going to get a pretty large number here. And I didn't bring my calculator with me, so I'm going to struggle to do this in my head. All right, 16 times 12 would be the same as 48 times 4, which would be the same as 200 minus 8, 196. You guys can check that and make sure it's right. And then 196 plus 25 would be, ooh, did I say 196? That should be 192. You know what, let me grab a calculator. Alright, yeah, 192, and then plus 25 equals 217. Alright, 217 is not the solution. This is the value of the discriminant. So I would put b squared minus 4ac, and that equals 217. Well, what does that tell us? We need to determine the number of real solutions. It's a positive number, so if it were underneath the radical 217, I would get a positive value. Now it's not a perfect square, so it's going to be an irrational number, but it's going to be around 14.7. So that tells me that we have 2 real roots. And I could go a little bit further and say I have 2 real irrational, and I threw in an extra R, irrational roots. That made it worse. Alright, let's take a look at B. Alright, again we want to move this guy over to the other side of the equals sign. So I'm going to add 4 to get rid of it, and then add 4 on this side, and I'm going to have 2x squared plus 3x plus 4. Don't try to add the 3x and the 4. They're talking about 2 different things. Okay, now I can say a equals 2, b equals 3, and c equals 4. And I'm looking for b squared minus 4ac, which is going to be 3 squared minus 4 times 2 times 4. And this is going to be 9. And I have one negative times a positive times a positive, so my answer is going to be negative. 4 times 4 is 16, times 2 is 32. And so 9 minus 32, well, 32 minus 9 is 23, so this will be negative 23. Alright, so my discriminant, b squared minus 4ac, is negative 23. So that means, because we have a negative under a radical, that means 2 imaginary roots. Alright, and that's what you're doing for the first part of this section. Alright, you can pause the video now and then work on some of these, and then I want to show you a trick with number 12. Alright, if you look at number 12, it's already equaling 0. So I can say a equals 16, b equals 16, and c equals 4. And that's fine. I'm going to have b squared minus 4ac equal to 16 squared minus 4 times 16 times 4, and 16 squared is 256. Yep, I just double checked it, 256. And then this is also going to be 256, because 4 times 4 is 16. 16 times 16 is 256. So this one's going to be 0. And if your discriminant is 0, that means you have 1 real root. And I prefer 1 repeated root. But either one of these is fine. Now, I said I was going to show you a trick, and that really wasn't a trick. This is how you would do it straightforward. And it's fine if you got a calculator or you know your perfect squares and your multiplication tables really well. Let's take a look at how I would do this, just so you know that the options out there. Okay, you see how 16 and 16 and 4 are not relatively prime? There's something you can divide out of each of these, and that would be a 4. I'm allowed to do that if I do that over here as well on the other side of the equal sign. So 16 divided by 4 is 4. 16 divided by 4 is another 4. And then 4 divided by 4 is 1. 0 divided by 4 is 0. And we've got a seemingly new equation here. A equals 4, B equals 4, C equals 1. Let's take a look at the discriminant. It's going to be 4 squared minus 4 times 4 times 1, which is going to be 16 from this guy. And 1 times anything is 1, so 4 or 1 is itself. 4 times 4 would be 16. Now the trick here is that you can get this done a little bit quicker because the numbers are smaller. And all I did was I noticed that 16, 16, and 4 share a common factor.